Alright, this is lesson 20-3, writing formulas and naming compounds. Sorry about that. So in this lesson, we are going to determine oxidation numbers, and you'll see what that is in a minute. We will write formulas and names for ionic compounds, and we will write formulas and names for, I should just say, covalent compounds. In this lesson, you are going to want to have a paper periodic table in front of you. Your instructor should provide you with one. You're going to mark this up, take some notes on it, and you'll be using it ultimately. So first, we need to talk about binary compounds before we can name them. Here's what a binary compound is. It is made of two elements. Okay? It's just a compound made of two elements. Examples? Well, examples include sodium chloride or table salt. We could also include potassium iodide. Again, just one, two elements make up that compound, binary compound. Or we could even have something like magnesium oxide. Okay? Two elements make up a binary compound. Fairly straightforward. So let's have some practice with binary compounds. On your screen, it should ask you to identify the binary compounds, which ones are, which ones aren't. That will let you know if you understood. Alright, so we're talking, are electrons gained or lost? So in all of these binary ionic compounds, okay, binary meaning two parts, two elements, ionic meaning we're gaining and losing electrons, so we need to know what's happening to these elements. Are we gaining or losing electrons? So an oxidation number. This tells you how many electrons an atom gains, loses, or shares to become stable. Remember our electron dot diagrams. Chlorine has 1, 2, 3, 4, 5, 6, 7 outer electrons. It wants 8 to become stable. So it's going to gain 1 to become stable. Since it gained a negative charge, remember electrons are negative, it's going to become Cl minus. Okay, so that's its oxidation number, is 1 minus. So there you go. There's Cl's oxidation number. On the other hand, our example down below, sodium only has one outer electron. It is going to lose that electron to get to the next highest energy level that's full already. So since it's going to lose one, if you lose something that's negative, you're going to become more positive. So sodium's oxidation number is 1 plus. Now we can also get other than 1 minus or 1 plus. Here's oxygen's electron dot diagram. 1, 2, 3, 4, 5, 6. Now oxygen is closer to having this energy level full, so it's not going to get rid of any. It's actually going to gain not 1, but 2. So now it's full. 1, 2, 3, 4, 5, 6, 7, 8. Since it gained 2 negative charges, now oxygen's oxidation number is 2 minus, or it's going to have a minus 2 charge when it becomes a negative ion. So, since you don't have to figure that out every time, or to make it easier for you, on your periodic table you are going to write down the oxidation numbers right here. Okay, so label yours. Label these numbers up here on your periodic table in front of you. Those are the common oxidation numbers. All of these get a 1 plus, all of these get a 2 plus normally, these 3, 4 plus, 3 minus, 2 minus, 1 minus, and 0. These are the noble gases. Okay? So for the most part, elements get those charges or those oxidation numbers. Except for there are some special ones. Copper and iron that we are going to look at. Okay? So all of these over here normally only have one, or almost always only have one oxidation number. These guys over here can have two different oxidation numbers, meaning copper can either be a 1 plus or copper can be a 2 plus. Okay? So this is going to come into play in just a little bit. But for right now, I'd like you to just write down these common oxidation numbers above your periodic table. So right now, I will pause the video in just a second. We're going to give you practice with oxidation numbers. Okay, so you are going to do a couple of questions or a question that will help you to test your knowledge on oxidation numbers. So now we have to ask ourselves, how many positive and negative ions must a formula have? Meaning, how come sometimes we're going to have NaCl and we're going to sometimes have things like CaF2 or, like I said, NaCl. How do we figure that stuff out? I'm going to tell you. So ions in an ionic compound have charges, but the compound itself does not. What's that mean? If we have Na plus and a Cl minus, you all went to kindergarten and you all know that plus 1 minus 1 equals 0. So if we take each of these ionic compounds as a whole, their charges are always going to add up to be 0. Okay? So what do we have to figure out? We have to figure out, we already did the sodium and chloride example. Now we're going to do this guy. So Ca, if we look at our periodic table, is normally a charge of 2 plus. Okay? And F, or fluorine, is normally a charge of 1 minus. Now I shouldn't have to show you, but I will. 2 plus, or plus 2, minus 1 does not equal 0. It equals plus 1. Okay? So we still have to balance out that other one. That's why we have 2 fluorines, because then we have 2 negatives and then 2 positives, so 2 plus minus 2, because there's 2 fluorines. Now we're balanced. So I hope that makes sense. Okay? I will ask you a question about that to clarify. So let's answer our next question. How do you find the correct subscripts when you're talking about ionic compounds or binary ionic compounds? So let's go through some examples. Aluminum and oxygen, we want to figure out what the correct subscripts are. So we know, let's first start out, we know that aluminum's symbol is Al and oxygen's is O. I'm going to go back to our periodic table and we're going to look at that aluminum's, okay, right here, its oxidation number is actually 3 plus. And oxygen's right here is 2 minus. Oops. So we go back and we know that aluminum is 3 plus, oxygen is 2 minus. I'm going to get rid of this right here. It's bugging me. There we go. And the simplest way that I found to do this is to get rid of the plus sign, get rid of the minus sign, and all you do is drop this number over there and drop this number over there. So we get Al2O3. And the last thing we have to do is see if they're balanced. So let's see if those charges balance out. So we know that aluminum is a 3 plus charge, and there are 2 of them, so we get a plus 6 total charge. The oxygen has a 2 minus charge times there are 3 of them, so we get a minus 6 charge. For all you math whizzes out there, if we take a plus 6 and a minus 6, obviously we get 0. So the charge is balanced. So we figured it out. The chemical formula is Al2O3. 2O3. Okay, charge is balanced. There's our ions. All right. Next, I would like you to try this example. Sodium and oxygen. You can pause your video now if I haven't done it for you, and try that one yourself. Try to balance that out, that chemical formula. And I will answer it in just a second. All right, so we're back, and let's go check the chart quick. Let's go see what sodium's oxidation number is. Sodium is right over here, so its oxidation number is 1 plus. And oxygen's we just did last time, it's a 2 minus. So we said the really easy thing to do is just to drop the numbers, just cross them around, and make sure you forget about the pluses and the minus. So all we get is sodium, okay, there's 2 of them, and oxygen, there should be 1 of them. Let's check our math and see if we made a balanced compound. So sodium has a plus 1 times there are 2 of them, that equals plus 2. Okay. And oxygen has a minus 2. So plus 2 minus 2 equals 0. We did it. Sodium, we have Na2. And guys, most of the time if we have a 1, we're just going to drop it. So it's just Na2O. Should be the correct chemical formula for sodium and oxygen in an ionic bond or an ionic compound. All right, I'm going to give you some time to practice. There should be a practice problem or two on the screen, so we'll pause it right here. Now we have to answer, how do you write the formula of an ionic compound? We've already learned all the steps. We just have to put them all together and give you a way to do it. So here are the rules. I would like you to take this time to write down the rules on either your note packet or if your instructor instructed you to just write it on paper. So take this time. I'll either pause the video or you pause the video, write these down someplace. You may ask your instructor if you have a question. So here's what we're going to do. Let's take an example. First, you're going to write the symbol. We're on step 1. Oops, got to go back. We're going to write the symbol of the ion with the positive charge first. So let's just do table salt as an example, sodium chloride. So the positive ion is always going to be sodium, okay, and we already know sodium has a 1 plus charge, okay, and then, so we've written it on the left, then we're on step 2, write the symbol of the ion with the negative charge. So Cl, if we looked way back at the table, has an oxidation number of 1 minus. Okay? Then 3, the number of the charge without the sign of one ion becomes the subscript of the other. There we go. Let's cross them over. So this one, we get rid of the charges and just cross them over. Okay? And since they're ones, we don't have to write it. And we did all that work just to figure out it is just NaCl. And if we balanced it out, we'd be a 1 plus a minus 1, which equals 0. Since we balanced it out, it's good. That is a binary ionic compound, okay, NaCl. So what you're going to do is now I'm going to provide you with some practice naming or practice with formulas for ionic compounds. You can take that time now. All right, so now the last question that we are going to answer in part A or part 1 of the 20-3 lesson is how do you write the name of a binary ionic compound? So what we've done so far, and let's use table salt again as an example, NaCl, we've done this. You've already learned how to write the chemical formula for binary ionic compounds. Now you're going to have to learn how to do this. Actually give the binary ionic compounds a name. Okay, we don't just call them that's NaCl or NaCl or that's table salt. That's just the common name. We actually have to have a scientific name. So you've learned how to do this. I'm going to teach you how to do this. So let's clear our screen here. So first, step 1, if we're going to name them, and let's do NaCl again. Just keep it simple. Table salt or sodium chloride. First, write the name of the positive ion. Okay? So what that means is you are going to just write the name of the positive one. So sodium in this case. Sodium. Next, look to see if the positive ion should say listed, not listen, in the special ions table. That's this guy right here. If it is not in the table, go right to step 3. If it is, the ion can have multiple charges. Pick the appropriate one that balances the equation. Write the charge in Roman numerals. Okay, so we'll pretend it's not in here, which chlorine is not in here, so we can proceed to step 3. 3. Write the root name of the negative ion. This is going to take some practice. So instead of chlorine, we just go with chlor. Okay. Instead of oxygen, we would just go with, that's the second step. So instead of chlorine, we'd write chlor. And instead of fluorine, we'd write fluor. Okay. So sodium, we write the root name, chlor. And then all you do, step 4, is add the word "ide" to the root name. So chloride. So we've named it sodium chloride. Now it gets a little bit trickier than this one. Okay, so we can have things like this: CuCl2. Okay. So let's pretend I used this copper, which can have multiple charges, so it's a special ion, Cu, and it's actually a 2+. And the reason that there are 2 chlorines, okay, 2 of them, is because chlorine is just a 1-. So to balance out the 2+ with minuses, we had to have 2 of them. So now we are going to do CuCl2 and follow our steps. So step 1, write the name of the positive ion. Copper. 2, look to see if the positive ion is listed in the special ions table. Yes, it is. If it is not, well, we can't. It is. If it is, the ion can have multiple charges. Okay, copper can be +1 or +2. Pick the appropriate one that balances the equation. So we already looked up here, and we determined that it had to be +2. So all you're going to do is put in parentheses the Roman numerals, okay, Roman numeral 2. If it was a Roman numeral 1 or a +1 charge, we'd put a 1. Copper 2. So we've got copper 2, and then we go to step 3, write the root name of the negative ion. So again, we have chlor, and then step 4, we just add ide. So the chemical name, or the name of the binary ionic compound that you see there, CuCl2, is copper 2 chloride. Okay. I'm going to run through one more example really quick. You'll say, what if it wasn't copper 2? What if it was just CuCl? And this Cu, this time Cu was a 1+ instead of a 2+, and a 1- for chloride, or chlorine. So step 1, write the name of the positive ion. Again, we write copper. Then look to see if the positive ion is listed. Yes, it is. So if it is, the ion can have multiple charges. Pick the appropriate one that balances the equation. Write the charge in Roman numerals in parentheses. So copper, we know this time it's just a 1, so it's copper 1, because it's just a +1 ion. Copper 1, and then again it's chlorine, so it's chlor is the root name, and then step 4, ide. Okay. Pretty simple. Now make sure you've got that down. Make sure you've written all those rules in your notebook, just like you did for writing down the chemical formula or your notes packet, whatever the instructor has provided for you, because now you're going to have some practice. Okay? Then that is going to take you into the last part of this exercise or this video. Part 2 will be coming either today or later sometime. This is just part 1. So what have we done? We've learned how to write the chemical formulas for binary ionic compounds, and we've also learned how to name them. Okay, so take this time, use the questions to practice.